Hey everyone! In this video I'm going to show you how to find sides in a triangle, and since we've already learned how to find angles in a triangle, that means we can find everything in a triangle, and finding everything in a triangle is called solving a triangle. So that's what solving a triangle means. So before we jump in, let's go over these steps. And first of all, let's review what we did last lesson. So to find angles in a triangle, first you need to do, you're going to need to do these three steps basically every single time you're using SOH CAH TOA. First step, you're going to need to identify the angle you care about. Last lesson, it was the angle that we wanted to find. In this case, it's going to be the angle that we know, because we're going to need to use that angle to find our missing side. Then next step, you're going to need to label your sides in the same order we always have, hypotenuse first, then opposite, then adjacent. Then you're going to need to set up your ratio using your SOH CAH TOA, whichever two sides you care about you're going to use. In this case, we're going to know one of the sides and we're going to want to find one of the other sides. And then step 4 is going to be different in this case. But first of all, let's go over these first three steps. They're almost the same as last time, just slightly different. So 1, label an angle you know. And in some cases, you might know more than one. And of course, this should not be the 90-degree angle. This should be one of the two acute angles in the triangle. But label the angle you know, because that's going to affect how you label your sides. So step 2, label your sides. And the order is going to be the same as always, hypotenuse, then opposite, then adjacent. Step 3, we are going to set up the ratio using one side you already know and the side you want to find. And sometimes there'll be a choice, particularly when you're solving a triangle, you're going to have two unknown sides possibly. Pick one and set up your ratio that makes sense for that side. And then finally, our solving step is going to be a little bit different. You are going to solve using algebra. And I'm going to show the cross-multiply method. I'm actually going to show you a slightly modified cross-multiply method that's a little bit easier, but I mean, it's roughly called cross-multiply. So quick recap, let's just do one of these solving an angle question just as a warm-up so we can see that it's basically very similar to what we did yesterday today. First step, we're going to label the angle that we care about. I'll call it, let's call it X, I guess. Then we're going to label our three sides, starting with the hypotenuse. Then across from X is the opposite. And the last side we have left is our adjacent. The two sides that we care about in this case are the two sides that we know, 13 and 44. Those are the adjacent and the hypotenuse. So we are going to use CAH to use the A and the H. I'm going to jump right into my equation with my substitution because I know cosine always has an angle with it. I guess let's color code that. So cos of X is a fraction, always a fraction, and our sides are going to be A first, so your adjacent is 13, and then the hypotenuse underneath is 44. Now to solve for an angle, this is what we did yesterday, you need to cos inverse your equation on the right-hand side. So remember when you move cos to the other side, it becomes cos inverse. So we are going to cos inverse our fraction, 1344. And when you plug all that into your calculator, if you round correctly and you plug it into your calculator correctly, you should get 73 degrees. If you don't get 73 degrees when you're doing questions like this, double check my last video to make sure you're using your calculator correctly, because that's probably the mistake you're making. All right, so we're going to do basically the same thing for these triangles, except instead of not knowing an angle, in this case, we don't know a side. The steps for the first three are basically the same thing. In this case, we know an angle, so that's the angle that we care about. That's the angle we're going to use. Then we're going to label our sides, hypotenuse first, then opposite, then adjacent. Now the two sides I care about, one of them is always going to be a side that I know, And the other side that I care about is the side that I'm trying to solve for, which in this case is x. And this is adjacent and hypotenuse again. That's fantastic. This is another CAH question. C-A-H, because we care about the adjacent and the hypotenuse. Cosine of our angle, and the angle we know in this case is 53 degrees. So that's the first big change from yesterday. Instead of putting a variable for the angle, we actually know our angle. So make sure you put that angle in with your sine, cosine, or tangent. Now when we set up our other sides, in this case we don't know our adjacent. Our adjacent is x, it's an unknown. And 19 is our hypotenuse, which we do know. So this brings us to our cross multiply step, or our algebra step. We have x. X is up top, up here. X is being divided by 19, right? This 19 underneath is division. So what's the inverse of dividing? The inverse of dividing is multiplying. So what you could do, sort of the long way to do it, sort of the grade 9 way to do it, would be to say, okay, I'm going to multiply this side by 19, I'm going to multiply this side by 19, and this is going to cancel, and this is going to cancel. And that's fine. That's fine. But what you'll notice, what ends up happening is this 19 underneath, here we go, this 19 underneath ends up top on the left-hand side. So I'm going to write this equation again and show you how I would do this in one step. Cos 53 degrees equals x over 19. All that I would do is I would cross the 19 off there, put a 19 in front, because I know that I'm multiplying by 19, which puts it in the numerator on the left-hand side. And that's all you need to do. So that means that x is the 19 times the cos of 53 degrees. So x is 19 times cos of 53 degrees. All right, now this is where we need to pause and figure out what kind of calculator you have. If you have a straightforward calculator, so you guys hopefully know what I'm talking about from yesterday. If you've got a straight forward calculator, then what you need to do is you need to plug in 19 times cosine. If it doesn't open brackets for you, it's a good idea to put a bracket. Some calculators already put a bracket, in which case you don't need that. But then you put 53 close bracket equals sine. And you should get 11.4 in this case. In this case, we get x equals 11.4. Another possible reason I just realized why you might not be getting the right answers is you need to make sure that your calculator is in something called degrees mode. And on your calculator, somewhere it should have a DRG button to switch between those three, or maybe a mode button that will let you choose your angles. But somewhere in your calculator display, it should say DEG for degrees. So you should get 11.4. If you've got a backwards calculator, it's a little bit confusing. The way the backwards calculators work, what you need to do is you need to put in your angle first, then you need to hit your cosine button. And you usually don't need to hit equals at this point. It should just give you a decimal number at this point. So you say 53 cosine, then you multiply by 19 and put in equals. And with the backwards calculator, you should still get this same 11.4 if you round correctly. So pause the video right now, make sure that you can plug this into your calculator correctly and get 11.4. All right, hopefully that worked for you. If not, let me know. Let's move on to another example. This example is going to end up being a little bit backwards for the algebra, so we'll see how that affects our answer. But our first few steps are always exactly the same. We start by labeling our angle, then we label our hypotenuse, our opposite, and our adjacent. In this case, we care about the hypotenuse and the opposite, because 15 is the side we know, and x is the side we are trying to solve for. SOH is so, right? When we care about the opposite and the hypotenuse, we are going to use sine. So sine of our angle equals a fraction, and our fraction is going to be opposite 15 over x. Now, x being underneath, x is our hypotenuse, it's underneath. O, we know it's up top. X being underneath actually makes this a little bit more complicated. You cannot solve for a variable in the denominator. So what some students want to do at this point is they want to get rid of the 15, and you can sort of think of getting rid of the 15. The opposite of a 15 up top is a 15 underneath, and then those would cancel. But the problem is that would actually leave you with 1 over x. Your x is still in the denominator. And so you haven't actually solved for x at this point. So let's undo all that and do it properly. Oops, there we go. So your first step actually needs to be get x out of the denominator. You cannot solve for a variable in the denominator, which means that we are going to cross multiply x to be in front. So x sine 38 degrees, so that's an 8, not a 6, equals 15. Now we need to get rid of this whole sine 38. Now remember, the 38 is essentially inside of the sine. You can think of it as if there's like brackets around this 38. The 38 goes with the sine. You cannot move the 38 without moving the sine with it. It's kind of like having, like a square root x. If you subtract a square root x and you bring it to the other side, you move the whole square root x to the other side where it becomes positive. If you have square root x in your numerator, let's say it's over 2, and you bring it to the other side, it should end up underneath, because the opposite of multiplication is division. But you notice the square root always goes with it. The exact same thing happens here with our sine of 38. Sine of 38 is one thing. And so what we're going to do is we're going to divide both sides by sine 38. And just like we were able to slide our x up top to move it, your sine 38 essentially ends up sliding underneath on the right-hand side. So if you want, you can just jump right to this step right here. X is 15 divided by sine 38 degrees. Now, the way you do this in a straightforward calculator, you literally do 15 divided by sine 38 equals. So that's your straightforward. Your backwards calculator is especially confusing for this one. So let's go through this very, very carefully. If you've got a backwards calculator, here's what you need to do. First step, you're actually going to do the 15 divided by. The 15 then needs to be divided by this whole thing. The way you do this whole thing is you do 38, then hit your sign button. So you say 15 divided by 38 sine. Notice you don't hit equal, and then the 38 sine on your calculator display will show at this point a decimal number. And then when you hit equal sign, that should then give you the correct answer. And the correct answer in this case is x is rounded correctly 24.4. So backwards calculator is confusing, I know. You do 15 divided by 38 sine equals. And that should give you 24.4 in your backwards calculator. All right, I want you to try these two questions right now. Question 4 and question 5. Unpause after each to make sure you get the correct answer. Okay, the answer for this one, if you rounded correctly, should be 18.6. And I'll just super quickly go do the solution. You care about this angle. This is your hypotenuse. This is your opposite. This is your adjacent. This is OA, so it's tangent. Tangent of 44 degrees is your opposite over your adjacent. X is underneath, so we need to cross multiply that in front. equals 18. Then we're going to take the tan 44 and put it underneath. And you plug this into your calculator, and there's your answer. Okay, question 5. If you did it correctly, x equals 7.9. And here's the full solution if you didn't get that. Here's my angle. This is my hypotenuse. This is my opposite. This is my adjacent. I care about the opposite and the hypotenuse. So this is going to be a sine question. Sine of my angle is my opposite over my adjacent, or my hypotenuse rather. The 10 underneath we're going to multiply in front when we cross multiply. You plug that into your calculator, you should get 7.9. Okay, we're going to move on to solving each triangle. First of all, I want you to notice at the top I say there are many ways to solve these. You can solve them in many different orders. I'm going to show you one way that you could solve these. You could have solved them in a different order and you should get the same answer. Aside from rounding, maybe if you only keep one decimal place, you might be off by a tiny bit, but that's okay. First step, regardless, we are going to label the angle we know, label our sides, the hypotenuse, then the opposite, then the adjacent. Now what's interesting in this one, there are two possible sides I could choose to solve for. I could choose to solve for the adjacent side, or I could choose to solve for the hypotenuse. And it really doesn't matter which one you do. I guess I'll use the adjacent, because why not? Oh, I circled the hypotenuse. I guess I'm doing the hypotenuse then. Sorry guys, I circled the wrong one. Doesn't matter, it really doesn't matter. That means we're going to use SOH. So sine of our angle, 40 degrees, equals our opposite, 12.1, over our hypotenuse. Okay, y is in the denominator. You cannot solve for y when it's in the denominator. So first step, we're going to cross multiply that up in front. So sine 40 degrees is still just chilling there. And that equals 12.1. Now I'm going to take this whole sine 40 thing and I'm going to divide it over to the other side. So y equals 12.1 over sine 40 degrees. Plug this into the calculator and I should get y equals 18.8. Now I know this is 18.8. Now, I could use the 18.8 to solve for the x, but I really don't want to do that. The reason I don't want to do that is because 18.8 was a rounded number. So when I'm using a rounded number, if I then use a rounded number to solve for x, I'm going to be rounding twice, which makes it less accurate. So the best way, the best choice for solving for x is to actually use the opposite to find the adjacent. And that way we aren't using any of our calculated values. Also, if you happen to make a mistake here, then you're definitely going to make a mistake when you solve for x. So I don't want to use that number if I don't have to, and I don't have to. That said, if you aren't a huge fan of SOH CAH TOA, you could use Pythagorean Theorem, is another choice. So at this point, I could do 18.8 squared minus 12.1 squared is x squared and go from there. But I'd really rather not use this 18.8 if I don't have to. And I don't have to, so I'm not going to. I'm going to use CAH. So cosine of my angle, 40 degrees, is equal to my opposite, 12.1, over my adjacent. Same steps as before. In fact, since we're going to do this so much, I'm actually going to do a double swap. I'm going to multiply the x up in front. At the same time, I'm going to take my cos 40 and multiply it underneath. Hopefully you're okay with that. If not, do it in 2 steps like we did here, and that's fine too. Now I plug this into my calculator, and I get x is 14.4. Last step. To solve this triangle, we still don't know this angle up here. I deliberately chose to do this last. I chose to do this last because having 2 angles in a triangle can confuse you about which side is your opposite and your adjacent. So I always solve for the missing angle last. And conveniently, conveniently, it's also the easiest thing to solve for. We do 180 minus 90 minus the angle we know, and that gives us 50 degrees. And there we have it. We have solved for our hypotenuse, we've solved for our adjacent, and we've solved for our missing angle. So triangle 6, we knew an angle and a side. Triangle 7, we know two sides. So this one, we need to solve for an angle first. Or I suppose we could use Pythagorean Theorem to solve for this side here. And we haven't done Pythagorean Theorem for a while. So actually, I guess maybe I will show Pythagorean Theorem to solve for that side. But let's pick an angle first, because this is sort of our process here. So I call that x. I guess I'll call this theta. I haven't used theta in a while. Theta being the Greek letter used for angles usually. So I'm going to choose to solve for this angle. That was a choice. I could have chose to solve for, let's say, beta, another Greek letter, over here if I like. But I'm going to solve for theta. So solving for theta, this is my hypotenuse, this is my opposite, and this is my adjacent. So I guess this becomes a CAH question. Cosine. Cosine of my angle is my adjacent over my hypotenuse. So theta is, remember, how do you deal with it when you've got cosine? The inverse of cosine is cos inverse. So we bring cos to the other side, it becomes cos inverse. Plug that into your calculator and you should get, I think it says to the nearest tenth, right? Yeah, nearest tenth. So since it says nearest tenth in the question, we'll keep to the nearest tenth. It's 32.2 degrees. All right, now let's solve for x. Since we haven't done it in a while, let's do Pythagorean Theorem. Everyone's favorite dead Greek guy formula. Okay, so x squared is long side squared minus short side squared. So x squared equals 169 minus 121. So x squared is, let's see if I can do this in my head, that's 48. And then we're going to need to square root both sides to get that x equals, rounded to one decimal place, is 6.9. Okay, and last step, and I always do this last step, remember, because I don't want to get confused about which side is my opposite and my adjacent. So the last thing I'm going to solve for is my missing angle. It's also the easiest step of all. 180 minus 90 minus the angle we just solved for, was 32.2. Subtract all that, and you're going to get, what is that, 57.8 degrees. 57.8 degrees. And there you have it. We've solved for our first missing angle, we solved for our missing side using Pythagorean Theorem this time, and we solved for our missing angle. And there you have it. That is solving triangles.